So on Wednesday's free response portion of the test, there's only 2 questions. One of the questions starts with a table and asks a bunch of things, and the other one starts with a graph, number 28, and asks a bunch of things. And then 29 is another graph, and 30 is a graph. So a very helpful review if you'll make use of it. Number 18. So again, this is Monday. This is the first period video, so it'll be 18, 21, 24, 27, and 30. All right, a bowl of soup is placed on the kitchen counter to cool. The temperature of the soup, a differentiable function t, is given in the table above for selected values of time t. Okay, so thing of soup starts at 105 degrees. It's going down. That makes sense. So it's cooling off. We don't have a function to think about. We just have this table of values. Find the antiderivative from 0 to 12 of t prime dt. Okay. This one is supposed to be an easy one, but it's going to get some people. So how do I do this one? Do you know? Is there a short way to explain it? I think the tempting thing to do is going to be a Riemann sum, but this is not a Riemann sum question. Yeah, it's the antiderivative of t prime, so that just gets us back to t. And our key points are 0 and 12, so t12 minus t0. And so all this one is 93 minus 105. That's negative 12. But there's going to be plenty of people who see a table, see an antiderivative, and immediately like, oh, Riemann sum, let's go. But the Riemann sum would give you the area under this curve. That's not what we want. Another clue would be it doesn't tell you whether you should use a right or left sum, so you wouldn't know which one to do. But the bigger issue is the antiderivative of the derivative gets you back to the original. Another thing that we've said a couple times is that if you integrate a rate, you get a change in the amount. If you integrate a rate, you get the change in the amount. So if I integrate the rate of temperature change, I get the change in temperature. So that negative 12 represents how much the temperature changed from 0 to 12. All right, using correct units, explain the meaning of, I think I just answered this question. Explain the meaning of what we just found in the context of this problem. So let's put units on this. These were both in Fahrenheit. So the answer was negative 12 degrees Fahrenheit. So there's my units, Fahrenheit. And the meaning is that's the change in temperature. And I guess we should be a little more specific. You might not get full points. What do you think I need to include in that to sort of finish my answer? The change in temperature. I need to be a little bit more specific. From 0 to 12 minutes, yeah. Or from t equals 0 to t equals 12. Part C, explain why there must be at least one value such that t prime at C equals negative 1. Okay, it must be at least one value of a derivative equals 1. That sounds like mean value theorem, where the algebra slope equals the calculus slope. Now, to use mean value theorem, the function has to be continuous and differentiable. but it tells us it's differentiable. So t is differentiable and therefore continuous. So MVT applies. And so I need, so they're telling me that the calculus slope is -1. So the calculus slope is t prime of c. I need somewhere for the algebra slope to be -1. So I basically need to look at all my different, possible slope combinations and figure out where I can get -1 from. Anybody see it yet? Let's see. That would be 6/5. That would be 2/3. That would be, there it is. So from 8 to 12, my temperature changes 4 degrees in 4 minutes. So that algebra slope is -1. So my algebra slope on 8 to 12 is 93 minus 97 over 12 minus 8. So -1 equals the derivative somewhere on 8 to 12. There you can see it. So that's an old MVT problem there. MVT is what's called an existence theorem, and like why something exists. So why there must be some value, that's a kind of a hint that we're headed toward MVT. The other hint was there's a derivative there. So that was a throwback question there. Part D, find the average rate of change of t. The average rate of change. Okay, so that's like the algebra rate of change. So that's just T8 minus T5 over 8 minus 5. So 97 minus 99 over 8 minus 5. I could stop there. That's a safe stop. Well, a little surprised it didn't ask for units. But degrees Fahrenheit over time is in minutes, I assume. It never says what time is in. Oh yeah, it does, minutes. So I can stop there, or I could say -2/3 degrees Fahrenheit per minute. That sounds like a rate of change. It's changing, it's going down 2/3 for each minute between 5 and 8. Okay, table question. And I thought there'd be a Riemann sum in there, but there wasn't, because it could ask all sorts of things. 21. If f and g are continuous functions such that g prime equals f, then the integral from 2 to 3 of f of x. Okay, well, if I integrate f, I don't get f, so I can throw that out. I throw c out. If I antiderivative f, I don't end up with the derivative of that. Those are opposite things. So it has something to do with g. Well, I'm just going to rewrite f is the same thing as g prime. So I'm going to just replace f with g prime. And I think that made my question a lot easier now, because now I've got the antiderivative of the derivative. So this I know how to handle. The antiderivative and the derivative cancel each other out. So g of 3 minus g of 2. So this is a very concept-heavy unit, meaning there's not a lot of, it's in there, like taking a derivative, plugging things in, that's in there. But it's also, I didn't have to know any derivatives here. I had to know concepts for number 21. 24. 23 and 24. There are two like this on the multiple choice test, and they're very similar. Then that one of them is you start with an integral and you got to find the right summation notation, and then the other one is 24 where it starts with summation and you got to find the right integral. Again, if you had to come up with one of these on your own, it might be a pain, but matching, hopefully we can make sense of this. So I'm looking for natural log. They've all got natural logs. That didn't help a whole lot. Natural log of 5 times something. Okay, they've all got that. Remember this? Maybe we should start where we started. This 8 was the b minus a. That's the width of the window, or the width of the area you're looking for. So I need it to be 8 wide. In fact, there you go. There's only one of them that's 8 wide. So it's got to be D. The other things that would help us, if it wasn't that one, wasn't obvious enough. Let's see. That number is where we start. So we're looking for a 6 at the bottom. And then again, that 8 is the width, the b minus a. So I bet C would be a common wrong answer, because you can spot the 6 and the 8 in there. But that 8 is how wide it is, not the top limit, not the upper limit. All right, number 27. Which of the following is an antiderivative? All right, I feel like that's a pretty straightforward question, so I'll let you do that one, and I'll pull a popsicle stick. Derivative of tangent is secant squared. Derivative of 2x is 2. So that one would be less concept, more do you know all the derivative rules? And so we're starting to get to the point where we're going to see everything on these tests. All right, number 30. A free response question with a picture. So I'm immediately thinking area under the curve, although when I look at the curve, I do not know how to find that kind of area, so maybe it's not area under the curve. Let's see. Continuous function f is defined on the closed interval -6 to 5, and this is the graph of f. The figure shows a portion of the graph of f. Oh, because the graph is defined from -6 to 5, but we only have the graph from -2 to 5. So there's something over here between -6 and -2 that we don't know. Let's see. 2 line segments and a quarter circle. Oh, okay, so I can find this area because this is a circle, or at least a quarter of a circle. Although it's this bottom part here, so be careful when we get to that. But I can do area, so I think this is going to be an area problem. It's known that the point 3, 3 minus root 5 is on the graph of f. 3, 3 minus root 5. So this is that point. I'm just going to call that A. It's on the graph of f. Okay, I don't know what that's about. I don't know how that helps me, but maybe something. Okay, if the integral from -6 to 5 is 7, find the value of -6 to 2. Show the work that leads to your answer. Okay, so the total area, which we don't have a picture of, is 7. Find the value of, I'm going to call this the missing area because we don't have a graph for that. But we do have a graph, so we can find the total area for the rest of this. So let's see, how can I write this? The area from -6 to 5 is the area from -6 to 2 plus the area from -2 to 5. How about that? So this total area is 7. negative 6 to 2 is what we're looking for. And then negative 2 to 5, we can find out by just adding up the areas. Okay. Let's see. So I'm going to just label them on the graph as I go here. So from negative 2 to negative 1, that's a positive 1/2. From negative 1 to from negative 1 to 0, that's a negative 1/2. Let's see, how do we want to break this up here? Minus, this would be, let's see, 1/2 base times height. That would be a 4th, so minus a 4th. And then this triangle is, that base is kind of a pain there. It's 1.5. So 1/2, 1.5 times a height of 3. Gonna have a big time safe stop thing going on here. And then I need this area. And that's like the big circle minus a, or excuse me, the big square minus a 1/4 of a circle. So plus, the big square is 3 times 3, and the 1/4 of a circle is 1/4 pi times r squared. What a pain. I tried to put all those pieces in there. Check to make sure this looks right. So that's a positive 1/2. That's a negative 1/2. That's a negative 1/4. And then this triangle is a weird shape, but that's it. And then this other weird shape of square minus a 1/4 of a circle. And is this a safe stop? Ooh. Why not, Tyler? You were shaking your head no early on there.
You have to move to 7.
Yeah, I need to make a calculator ready. I need to solve for this thing. So I'm almost there, but not quite. So I think I'm trying to figure out the easiest way to write this. I think it would be to just move all of this over. So I'm going to say 7 minus. And then I'm really not going to do any of the stuff in there. I'm just going to leave it all there. 1/2 minus a 1/2 minus a 1/4 plus, that doesn't even really simplify nice. So leave it. 1/2, 1.5 times 3 plus 9 minus 9 pi over 4. Yuck. But I mean, kind of a pain, but no individual piece of it was that hard. You just had to put it all together. Part B. Evaluate from 3 to 5 2f prime plus 4. Okay, well let's break this up a little bit here. So 2 times f prime plus the integral from 3 to 5 of 4. Okay, the second part, this is one where you can do by hand and do 4x and then plug in 5, plug in 3. But you can also do the geometry way, like the area way. If the height is 4 and we're going from 3 to 5, then the area of that thing is 8. So again, if it's just a number there, you can think area, or you can think 4x is the antiderivative. And then plug in 5 minus plug in 3, 20 minus 12. Either way you go, you get 8. So that part's 8. That's the easy part, I think. So this first part, is this the area under my curve from 3 to 5? under that curve from 3 to 5? You're shaking your head no. It's the area under f prime, but we don't have f prime. But let's back up. This is the antiderivative of the derivative. So that's just f of 5 minus f of 3. The antiderivative of the derivative gets us back to the f of 5 I can get from the graph. That's 0. F of 3, they gave me f of 3. I didn't know why they gave me that weird point, but now I know. F of 3 is 3 minus root 5. And the plus 8. That's a safe stop, so I guess I could ignore the 0 and distribute the stuff, but just leave it alone. If you have the chance to leave it alone, leave it alone. Okay, find this limit. Okay. So what's our first go? We haven't done limits in a while. But what's our first, what's our first attempt, or what do we do first if we're doing a limit? Just plug it in and hope that it works. So let's plug in 1 and hope that this thing works. So 10 to the first minus 3 f prime of 1 over f of 1 minus arctan of 1. Okay. Some of this is easy. 10 to the first is 10. F prime at 1. How am I supposed to know what f prime at 1 is? Yeah, that's the slope of f at 1. So I look on my graph. There's 1. And that slope, it's just a line, so I can just count the slope up 2 over 1. That slope is 2. So 10 minus 3 times 2 over f of 1. That's just on the graph. F of 1 is 1. The arctan of 1. Well, that's a safe stop because that's a calculator thing. So I would hope you know the arctan of 1. So do you remember what angle has a tangent of 1? Do you remember what angle has a tangent of 1? Yeah, pi over 4. You're thinking the middle one? Is that what that's? I recognize the middle angle. You were signaling the middle angle and you're right. So yes, pi over 4. But arctan of 1, that is a calculator ready thing. So if you didn't remember that, you could leave arctan of 1. I mean, I guess I could clean that up a little bit, but there's no need to. With limits, I should make sure that it's not like 0 over 0, because I can't do that. But this is 4 over something weird, so it's a regular number. So there we are. So that was an interesting question, just a way to test, I guess, 4 different things all in one problem there. But there was a lot of good stuff in there. The slope you had to pick from the graph. F of 1 you got from the graph. The others were just more straightforward. Okay, so the other parts of 18 through 30 will be in other videos posted later today.